During this video, we are going to review the concept of electron or electronic configuration. Before we start doing some practice problems, we have to remember some important concepts, okay? All elements can be described by their energy level, sublevel, and number of electrons in each sublevel, okay? When we have an atom or when we have an element from the periodic table and we want to define their electronic configuration, what we have to know or what we have to remember is the off-bow diagram, okay? This diagram, okay, show us the order in which we have to fill the energy levels, sublevels, and electrons in each one of the sublevels of energy, okay? The order or the way to read it is in diagonal, starting from the top, and then we move in each one of the diagonal lines in order to form the electron configuration. We have to remember the maximum amount of electrons that each one of the sublevels of energy can hold. The sublevel S can hold a maximum amount of 2 electrons. The sublevel P can hold a maximum amount of 6. The sublevel D can hold a maximum amount of 10, and the sublevel F can hold a maximum amount of 14. Okay, so before moving to another sublevel of energy, we have to complete the previous level, okay? This chart, you have to know how to build it, okay? In order that you do not have problems by the time that you solve the problems. Okay, so we are going to practice with one element, calcium. Calcium, its atomic number is 20, okay? The Z is 20. So if we look in the periodic table, we will see that calcium has an atomic number of 20. That atomic number tells us how many protons we have, okay? So we have to place these 20 electrons, okay, in each one of the energy levels, sublevels of energy, etc. Okay? So in order to place these 20 electrons, we're going to start with the first energy level and its sublevel. So we start with 1s. The maximum amount of electrons that S can hold is 2. So I'm going to place 2 electrons, okay? This 2 tells me that of the 20 electrons that calcium has, okay, I will be placing 2. Okay, so in this moment, I already placed 2 electrons and I'm still pending of placing 18 more. Okay, so I will move to the next one. The next one is going to be 2s. Okay, so I'm going to write 2s. The maximum amount of electrons, once again, that S can hold is 2. So if now I have placed 2 plus 2, 4, and I still have 16 more to place. So I will be moving to the next level of energy, which is going to be 2p. And now P has a maximum amount of 6 electrons that can hold, okay? Why am I writing 6 and not 5? Because before switching to another energy level, I have first to complete the previous sublevel of energy, okay? So if I add, let me change the color. If I add 6 plus 2 plus 2, now I have 10. Which is not the 20 that I need. I still have, or I need 10 more electrons to place. So I will move to the next one. After 2p, okay, now we have to move to 3s. Okay, so I'm gonna write here 3s2. So now I have 6 plus 2 plus 2 plus 2 more. Okay, so now I have 12 and I need 8 more, okay? After 3s, okay, the next one or the next level of energy that I have is going to be 3p. Okay, so I'm gonna write 3p6. Okay, I have 6, 8, 10, 16, 18. Okay, so now with this 6 that I add, okay, I have 6, 8, 10, 12, 18. So instead of having 12, now I have 18, okay? And I need 2 more. So after 3p, okay, what I have next is going to be 4s. Okay, so I'm gonna write 4s 2. Okay, now if I add all the numbers that I have in each one of the sublevels of energy, the sum of all of them is going to be the 20 that I have of calcium. So we have 6, 8, 10, 16, 18, and 20. Okay, once that I have the amount of electrons equal to the atomic number that we had, it means that I will stop my electron configuration and this will be my final answer. Okay, so the electron configuration for calcium, which has an atomic number of 20, will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Okay, now let me make another one, but I will erase this one first. Okay, we are going to make vanadium. Okay, I'm gonna go a little bit faster since we already know what to do. So I will start with the first level, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. If we sum the exponents, okay, we have 2, 4, 10, 12, 18, 20, 21, but we need 23. So instead of writing 3d1, I'm gonna be writing, sorry, instead of writing 3d1, I'm gonna be writing 3d3. Okay, remembering that D can hold a maximum amount of 10, so I can write 3d3. And this will be the electron configuration of vanadium, okay? We cannot have previous sublevels of energy incomplete, okay, before switching to another one. I cannot have here a 5, okay? In this case, I cannot have here a 5 and then move to the next one. Every sublevel of energy must be complete before I switch to the next one, okay? And be sure to remember how to fill or the order of the off-bow diagram, okay? Remember that it's in diagonal, okay? Starting from with the sequence of the arrows, we start with 1s, and then it's 2s, then 2p, 3s, 3p, 4s, and then we switch to 3d, 4p, okay? This is the part in which can be a little bit tricky because after 4s is not 4p, it's 3d, okay? So be sure to follow the correct order before you switch to the next level of energy.